the images that we've been getting and the science we've been getting from Pluto is really just been, more than amazing, and proves definitively a scientific theory that science never sleeps. And if you look at our panel here, they actually look pretty cheery for a group of scientists that have not been sleeping for the last few weeks. But they are here to tell us about the most recent amazing results from the Pluto New Horizons mission. And I'm just thrilled to be here to hear those results.
It's a very successful flyby of the New Horizons spacecraft through the Pluto system. And we're just 10 days from that. And yet we've only had about an opportunity to see about 5% of the data. As many know, we stored that data on board as we flew through the system, and it's just now starting to come back. Each and every day, the science team has been huddled, looking at the data as it comes back, and is always surprised. And it's just quite a pleasure to be part of that team, to look at the data when it comes in, and see the new discoveries that are coming out.
Last week, the United States, through our project and NASA, explored the farthest frontier ever explored by humankind, the Pluto system. And we can't tell you how happy we are just to be back as a team and to tell you what we've been discovering. We came back last Friday and gave a first report about just the first couple days of data download and the first reactions that we had to it. Now we're 10 days out, 7.5 million miles from Pluto. We've had more time to think about the data sets that are on the ground, and equally importantly, we have about 3 times as much data on the ground. Now, that, as Jim said, it's not very much of the total data load. We have about 4 to 5% of the data back. 95 or 96% of it is still on the spacecraft, so we're only scratching the surface, and we've got some great discoveries to tell you about. We also want to tell you that besides the data sets, there's one other way on this project to know that we've really done the exploration. We're on the other side of Pluto, and that's this bumper sticker that's inspired by Val Malder, our deputy systems engineer. It says, "My other vehicle explored Pluto." It's got a nice picture of Pluto made by New Horizons in the rearview mirror. That's how you know. This has twice the resolution of the previous best global image of the approach hemisphere. And really, it's just mouthwatering. The level of detail is spectacular. We're going to look at just the northern half of that image. And we could easily blow it up even further. And you can see across the northern terrains here, which include the North Pole, by the way. And, this is a true color image, essentially true color as your eye might see it, a whole range of geologic expression. I'd like to close with one more time step. This is really a spectacular image. This is a silhouette of Pluto looking back after the flyby. I think this is just fantastic. This is our equivalent on New Horizons of the Apollo Earthrise photograph that proved we were there. You can only get this image by going to Pluto and crossing to the far side and looking back.
In a planetary atmosphere, the surface pressure at any level is a measure of the weight of the air above that level. And weight is gravity acting on mass. So if you know the surface pressure of a planet's atmosphere, you can get a pretty good estimate of the total mass of that atmosphere. And it's important because that's a way of quantifying the global state of an atmosphere. Okay, so I can have a next plot, the next graphic, please. Okay, this shows surface pressure on Pluto as a function of time. Now the units might be a little bit strange to you. They're in microbars. A microbar is 1/1,000,000th sea level pressure on Earth. And the time scale there is from 1989 up to just before the present. Now, what is interesting here is that in 1989, Pluto was at its closest distance to the Sun. And now Pluto is moving away from the Sun in its very elliptical orbit.
It takes 248 years for Pluto to go around the Sun. And Pluto has a very eccentric orbit. So sometimes it's much closer to the Sun than at other times. Also, additionally, Pluto's North Pole is tilted over at an angle of about 120 degrees relative to the plane that it orbits in. All of these factors together cause different parts of Pluto to get different amounts of sunlight. And the sunlight is powering the sublimation of the ices from the surface into the atmosphere.
Something that to a geologist's eye looks like something that has been very deeply and extensively eroded. And we can tell it's old as well because you can see with your own eye various impact craters of large size. But what's really interesting to us is the actual interaction between the Sputnik planum and this rugged terrain to the top. If you look carefully at the image, you can actually see a pattern that indicates the flow of viscous ice towards the scarp or cliff boundary of the rugged terrain. But water ice at Pluto's temperatures won't move anywhere. It's immobile and brittle. But on Pluto, the kind of ices we think make up the planum, which Kathy just talked about, nitrogen ice, carbon monoxide ice, methane ice, these ices are geologically soft and malleable even at Pluto conditions, and they will flow like in the same way that glaciers do on the Earth.